Good afternoon, everyone. I'm so glad and excited to be here with you. I'm going to share our research, which is about addition of Chitosan to ultrafiltration membrane and using it for the removal of direct red dye 23, especially. We are going to take our agenda for today. We are going to begin with the introduction, theoretical part, experimental procedure, membrane characterization, results and discussion. For the result and discussion, we have two main points. We use to relate between the dye concentration and the percentage of dye removal. And the second point will be the effect of the dye concentration on the flux of membrane 2 and membrane 3, as we have 3 membranes under examination. Membrane 1 is polysulfone ultrafiltration membrane. This membrane is unmodified. Membrane 2 is a modified membrane with 0.7 Chitosan, 0.7% Chitosan. Membrane 3 is also ultrafiltration membrane with 0.2% Chitosan. And finally, will be our conclusion. No one can deny that dyes from wastewater, from the textile industry especially, has been challenged to eliminate. Many methods were used, biological, chemical, and physical. But here today, we are going to focus on a physical method and technique, which is filtration, and by using ultrafiltration membrane, especially. If we are going to take the dye effluent on all the humans, it is carcinogenic, of course. For the plant life, we can see that it interrupts the photosynthesis and cause to be high level of danger on aquatic life. We are going to the theoretical part. Of course, the ultrafiltration membrane is a physical technique that we use for the separation and filtration for direct red dye 23 especially. We chosen that method especially because it is eco-friendly, and second, it can separate, regenerate the expensive chemicals and from it the dyes. Also, it is eco-friendly, and for the cost, it is mainly a little bit low. For the experimental part, we can see that we have made a pilot plant under the supervision of the Egyptian Society of Membrane Technology. It contains mainly of feed tank receiver pump to maintain our pressure at the atmospheric pressure. And we have two modules, one vertical and one horizontal. The vertical one contains activated carbon. The horizontal one contains our unmodified and modified ultrafiltration membrane. For our experimental procedure steps, we first of all make ranges of dye concentration ranging from 10 parts per million to 50 parts per million using tap water, especially. Then after that, we have made different batch runs using different contact time from 5 minutes to 30 minutes. After that, we have measured the percentage of dye remaining by quantifying absorbance using spectrophotometer. We then, after that, make forward and backward wash for the membranes to maintain our outlets clean. We had used different techniques for membrane characterization, the SEM, FTIR, and then water contact angle. These techniques, especially to say how the structure and the properties of the membranes had changed by addition of Chitosan. You can see in the figure that we have cross-section area for the three membranes, membrane 1, 2, and 3. And we have said before that membrane 1 is the unmodified one, membrane 2 is the modified one with 0.7 Chitosan%. Membrane 3 is the also unmodified ultrafiltration membrane with 0.2% of Chitosan. We can see that the three membranes had the same asymmetric structure with top dense layer and support layer. But for membrane 1, we can see that we have less macrovoids and narrow channels. But for membrane 2 and membrane 3, that by the addition of Chitosan, we can see that we have more macrovoids and more channels, wide channels, and this also help in the flow rate of the and the flux of our procedure. Okay. And we can see after that we have made a membrane characterization also using another technique, which is FTIR. FTIR, mainly this technique is used to ensure that Chitosan was added. We can see at the figure of M2 and M3 that we have a peak at 3362. Sorry. Wave number. This wave number, this peak, and at the spectra of M2 and M3 only, which prove that there is a hydroxyl group attached to the Chitosan, and that Chitosan is present. Returning to the three membranes, we have three peaks that are common at the three membranes. At 1137 wave number, we can see the sulfonic group, and at 1237 wave number, we can see the ether aromatic group. At 834 wave number, we can see a peak of aromatic group. This means that the three membranes have the same base material, but M2 and M3 only have Chitosan. After that, we have made another membrane characterization, which is water angle contact using water angle meter. We can see that this special membrane characterization is to identify the hydrophilicity of the membrane. As we have less water contact angle, we have more hydrophilicity. We can see from our results that M2 has the least water angle contact, and the higher water angle contact will be for M1. This means that the hydrophilicity property had been added to the membrane by the addition of Chitosan. The hydrophilicity property enhance the water molecule to contact with the membrane and so increase the flux. We are going down there for our results and discussion. As we said before, that we are going to say about the relation of the dye concentration, different dye concentration on the percentage of dye removal. And we are going here to speak about the extremes, the 10 parts per million and the 50 parts per million only. But the full paper have all the ranges. For 10 parts per million, as we can see, M1 has dropped from 48% and sharply to 12.8%. The percentage of dye removal, and for M2 and M3 have shown 63 and 88% respectively. For 50 parts per million, we can see that M1 also had dropped from 39% to 12.6%, but for M2 and M3 has 88 and 63% respectively. And this is obvious that the addition of Chitosan has improved the percentage of dye removal. We can't deny it. Second result we are talking about for the membranes M2 and M3 only. We are going to see the effect of different dye concentration on the flux. Here is M2, M3, and here is M2. Please remember the figures. You can see that it's similar somehow because it's like that. It's similar somehow. We can see that M2, especially with the ultrafiltration and the modified ultrafiltration membrane with 0.7 Chitosan%, had been higher than M3 with 0.2% Chitosan. For all the results, for all the concentrations, but we can find that for the concentration from 30 to 50 parts per million, after about 15 minutes from our procedure, that the results converge. Of course, for our conclusion, finally, we can't deny that addition of Chitosan had enhanced every properties for the ultrafiltration membrane. And we can see that it offers best dye removal. It has increased the membrane hydrophilicity and reduced water contact angles, a change in pore structure. So the FTIR and the membrane characterization had proved it, and had proved that for M2, or the FTIR for M2 and M1 and M3, we have the same similar base material. But for M2 and M3 only, Chitosan have been added. And we can say that for our future, inshallah, discussion will be using different types of addition to the ultrafiltration membrane to enhance the percentage of dye removal and also give more flexibility. Thank you very much.